Hi everyone! This series of videos will take you through lesson 9G, which is a good indicator of the types of problems you're going to start to see in the bigger picture that involve logs. Many of the problems that you'll see in math analysis, and even if you go further into calculus, often involve solving equations that have logs as part of the equation. So while we've learned lots of things like properties of logs and all the different ways that logs can show up, it's important to keep in perspective where those things end up, and it's really in solving equations that logs do the most good. You're rarely going to be asked to just do log problems out of nowhere. It's usually going to be in a solve for x kind of context. So one of the things that I find the most helpful is to remind myself when the instructions say solve or solve for x, you're really just trying to figure out what x needs to be to make the left-hand side of the equation equivalent to the right-hand side. By phrasing the instructions in such a way, it can often significantly simplify what you're trying to do. For instance, in question number 1, if I just think of the left side of the equation and the right side of the equation as two separate quantities, I just want to compare them quickly. Log of 2 times something is supposed to be the same as log of 22. Well, I know that they're both logs, so it's not really like those parts I need to worry about. Those are already equivalent. So I'm looking at the 2x and the 22 and just asking myself, what would x need to be to make the left equivalent to the right? Well, 2 times 11 is definitely 22, so I know that x is 11, because that would make the left side match the right side. Now, of course, if you wanted to, you could check that very easily with any calculator that has a log button. You could type log of, and in the parentheses, 2 times 11. You'll get a decimal, but nobody cares what that decimal is. All you need to do is check the other side of the equation, log of 22, and verify that you get the exact same decimal. So it's worth noting that if you want to have a calculator available for these things, you can definitely use it, but you might not need it. It may just be that your common sense kicks in at this point, and you don't have to worry too much about what the log is doing, and more importantly, just focus on what makes the left side match the right side. So in question number 2, kind of the same idea. Just ask yourself, what makes the left side of this problem equal to the right side of this problem? So the logs are already equal. It's almost like visually I don't need to even look at those because those already match. If the whole point of this is making the left side match the right side, focusing on the logs isn't going to do anything because they both already have a log. It's the x, 3x minus 1 specifically, that has to match 38. Now some people hear the word match and they immediately think equal. That whatever 3x minus 1 is going to have to give me 38 as a result. And some people just naturally think in terms of algebra here. They think, well, that's just an equation. I could just solve that if I needed to. If I move the 1 over, 3x would have to be 39. And if I divide by 3, x would have to be 13. So we could tell ourselves pretty quickly, well, x must be 13. And again, if you're not sure, then just grab a calculator. Log of 3 times 13, or you can do parentheses, minus 1. You'll get a decimal. Nobody cares what the decimal is. You just want to verify that if you type log 38, the part on the other side of the equation, you'll get the same decimal. And you will, if everything goes correctly. So think about this however you want to for number 3, but I'm going to skip ahead to question number 4, only because that one's a little bit different. All of a sudden we're seeing in question number 4, we don't have a log on either side. Now it's like I'm comparing things that really don't look similar at all. Log base 2 of x squared equals, well, this isn't log base 2 of 4, it's just a 4. So now I'm asking myself, okay, wait a minute, hold on. If now I'm not comparing the left side to the right side, if now it's not an easy equivalence, what else can I do? What else do I know about logs that could help me here? And one thing that might be familiar about logs is this sort of structure that we can rewrite, this exponential equivalence. We know that if we had to, we could look at anything with a log on one side and a number on the opposite side, and we could write it exponentially, so that the base of 2 to the power of 4 could equal whatever's in the center there, x squared. And then I could look at that and say to myself, well, that's an equation I can solve. That's an equivalence I can work with. 2 to the 4th is 16 equals x squared. And that's definitely an equation I can work with. I can square root both sides, and I know that I could have positive 4 or negative 4 as possible answers for x. So again, sometimes your algebra instincts take you in different directions than in some of the other examples, and that's totally okay. So if you see a problem that has just a single log on one side of the equation and an integer on the other side, consider writing it exponentially. So that way you can let your algebra instincts be your guide. Number 5 is another example of such a problem, where you have a log on one side and a number on the other side. So you could just rewrite it exponentially to see what happens. If we rewrite it exponentially, same pattern, base of 2 to the power of 5 would equal to 3x plus 2, whatever that is. I don't know what 3x plus 2 is. I'm not going to worry about that, but I'm going to definitely take care of 2 to the power of 5. That's 32 equals 3x plus 2, and hopefully now your algebra instincts have kicked right in, because you can tell yourself, oh wait, I know how to solve for x. I could move the 2 to the other side. I could divide both sides by 3, and we end up with x is 10. So again, the point of these is to let your instincts kick in. I know that in many cases it's really hard to have algebraic instincts with logs, so the point of these questions is to try to rewrite as many of them as you can so that you can let those instincts kick in. Try for the next few moments to do the following problems. I'm going to highlight some that I think you should be able to do right now, and then in a separate video I'll do some different ones. So here are the ones that I think right now, with these examples, should be pretty doable. Obviously numbers 1, 2, 4, and 5, because we've already done those. But I think you could also do 3. I think you could do 6. I think you can do 7, all very similar. I think you could do 9. I think you can do 10. I think you could do 11 and 12. Actually, and 13. So look at how many examples I think you can pull off using just what you've learned in this video. I purposely didn't select 8, 14, and 15, and if you noticed why, you're probably a step ahead there. If you already noticed why I didn't pick 8, 14, or 15, it's because they all have something that tie them together that I'll use in another video so that you can kind of mentally separate those. And if you can, between now and the time you start the next one, do the circle problems and check your answers for those, either in a calculator or using the answer key. Then, when you're ready for the next video, we'll do 8, 14, 15 separately.